In this lecture series, we are going to learn about the graph and we are going to prepare for them from the perspective of interviewing. And also we will be solving some lead code exercise that will help us improve our knowledge and better prepare for the coding interviews. Okay, so what is a graph? It is a collection of nodes and edges where nodes represent entities and edges represent relationship between those entities. So this is a very simple definition and it will get more clear if we look at the examples. So here, see, this is an example of a graph. Here we have graph that represents different entities, which are people over here, and the relationship, the edges, they represent friendship between them. Okay, so this is a Facebook like graph where when two people they are joined by an direct edge, that means they are friends. So here you can see that Ben is friend with Chloe and Eva is friend with Jack, right? And Ivy is friend with Hugo. So they are friends. And here we can see that Hugo is a friend of Ivy, but Hugo is not a friend of Jack, or Hugo is not a friend of Eva because it is not directly connected with them. Although they are here, the Eva is friend of sorry, the name of both of these is Eva. So this girl Eva is not a friend of Hugo, but she is friend of another girl who has the same name as Eva, and she's a friend of Hugo. So this is a Facebook like graph, and here you can see that the relationship between any two people, for example Ben and Chloe, is they are friends with one another. So if Ben is a friend of Chloe, then Chloe is also a friend of Ben, and therefore this relationship goes both the ways, right? And it does not have a direction, so it is also called as a undirected graph. Okay, now moving to the next example. This is also a example of a graph, and here the nodes they are also representing different people, and the edges between them represent whether they follow one another or not. So follow, it's an Instagram thing where if you follow someone, that means you will see all the posts they will be posting on their Instagram account, right? So here for example Alex follows Hugo and Alex also follows Chloe, right? So anytime Hugo or Chloe will be posting, Alex will see their post, right? But Hugo does not follow Alex and Chloe also does not follow Alex, right? So it's a one-way thing. But in some cases, for like this one, Ben follows Chloe and Chloe also follows Ben. So it's a bi-directional relationship, right? So but here between the Alex Hugo and the Alex Chloe, it is unidirectional. So such kind of a relationship where there is a the edges they have a direction, they have a meaning, are called directed graphs. So the graph which are directed graph, the direction of an edge has a meaning. Now let's come to another example. Here we have different places and they are connected to one another, right? So if you can go from Rome to New York, and if you can go from Rome to Tokyo, then that means you can also go back from Tokyo to Rome or New York to Rome, right? So these edges they represent the path between those different cities, and here this is a graph where you can go from one city to one another. If you want to go from San Francisco to Cairo, you have to first go to Tokyo and then you have to go to Cairo. Okay, now here in this different example we have the same cities, but here you can see that there is some weight that is associated with the edges. So the edges also have some weight, and this weight can represent different things. For example, this weight can represent the price for the fare between these two cities, the ticket price to go from one city to another city. For example, 800 can be the price to go from New York to Tokyo, right? The edges can have some meaning, and we can use this kind of information to calculate the minimum price for going from one place to another place for such kind of use cases. right? And this is also helpful in another examples, for example, like in a map where you have different paths going to the same position. If I'm at one place and I want to go to another place, there can be multiple routes, right? But the one with the least weight, where the weight can be the waiting time, the time taken to reach that place, or the distance, or the price, that can be optimized. So here such kind of a graph, they are called as weighted graph, because the edges have weight, and earlier the edges did not have any weight, therefore this is unweighted graph. Now moving to the next one. Up until now, all the graphs that we have seen, all the different nodes, they are connected to one another directly or indirectly. Therefore you can go from one node to another. If you look at all these examples from before, they are connected to one another directly or indirectly. You can go from one place to another, from one node to another. But in this example, we can see that these three cities, they are separated. So if you are in Rio, then you cannot go to Dublin, right? That is not possible because there is not a direct or indirect path that goes to the Dublin. So such kind of a graph, they are called as disconnected graph. So there is a disconnection, they are not connected. They all the nodes, they are not connected directly or indirectly. Such graphs are called as disconnected graph. Whereas graph where all the nodes, they are connected directly or indirectly, are called as connected graph. So in connected graph, you can visit all the different nodes in single traversal, whereas you have to make multiple traversal. You have to make one traversal for going through this one, the Paris, Rome, San Francisco, all of these cities, and you have to make another traversal to go through these three different cities. So this was disconnected graph. Now coming to another kind of a graph in which from every single city I can reach every other city directly. So all of the nodes, they are connected to one another. Such kind of a graph is called as complete graph. Okay, so now there are two different graphs as well, based upon the connectivity. So based upon the presence of a cycle. A cycle, if it exists in a graph, then it is called as a cyclic graph. And what I mean by cycle is, a cycle is when you can go from one node and reach the same node again. So I can start from node A, and by moving in this graph, I can reach back to A again. Therefore there is a cycle in this whole graph, and it's a cyclic graph. But in case of this one graph, I cannot reach one node from itself. For example, if I go from F to G, then I cannot go back to F. So this is a cyclic graph. And now this is another example of a graph. So the tree, it is also a graph. It is a special kind of a graph. In a tree, there are no cycles, and there are no cycles, and the edges, they are directed from parent toward the children. So it's a special kind of a graph that is called as directed acyclic graph, also known as DAG in short. So congrats, these are the different kind of graphs that we have